Welcome back. In our last episode, we explored upper winds and jet streams. Now, we turn our eyes to something we see every day: clouds. In this episode, we'll uncover how clouds form, how to identify them, and what they mean for flying. Let's start with the basics. A cloud forms when moist air rises, cools, and condenses. As the air cools past its dew point, water vapor turns into tiny water droplets or ice crystals, visible as clouds. But not all rising air forms clouds. You need enough moisture, the right temperature, and a lifting mechanism like terrain, fronts, or convection. Without one of these, the air might rise and cool, but not form a visible cloud. There are four major lifting processes. Orographic lifting, when air is forced up over terrain. Frontal lifting, when warm air rides up over cold air. Convection, when heated surface air rises. Convergence, when air flows together and is forced upward. Each process creates different cloud shapes, altitudes, and weather patterns. For pilots, recognizing these types is essential for anticipating visibility, turbulence, and icing. Clouds are classified by altitude and appearance. There are three main levels. Low clouds, surface to 6,500 feet. Middle clouds, 6,500 to 20,000 feet. High clouds, above 20,000 feet. Now let's break down the major cloud families. Cumulus, puffy, heaped clouds formed by convection associated with good weather or building thunderstorms. Stratus, flat, layered clouds often bring fog, drizzle, or low ceilings. Cirrus, thin, wispy clouds high in the sky made of ice crystals. Nimbus, rain-bearing clouds often dense and grey. These can combine into names like cumulonimbus, towering thunderstorm clouds. Stratocumulus, low, lumpy layers. Nimbostratus, widespread rain producers. Altostratus, grey middle layer clouds. Let's visualize a cloud hierarchy from low to high. Stratus, stratocumulus, and fog live near the surface. Altostratus and altocumulus occupy the mid-levels. Cirrus, cirrostratus, and cirrocumulus float high above. Cumulonimbus stretches from low levels to well above FL 400. For pilots, each cloud type signals different conditions. For example, cumulus equals potential for thermals and light turbulence. Stratus equals smooth ride but low visibility. Cumulonimbus equals avoid at all costs, severe turbulence, hail, lightning. Let's talk about vertical development. Cumulus clouds can grow into towering cumulus and eventually into CBS, cumulonimbus, given enough moisture and instability. The more vertical the cloud, the more energetic the atmosphere. If you see cumulus clouds flatten at the top, forming anvils, that's a sign the air has reached the tropopause. This is the top of the weather-producing layer, and it signals mature thunderstorms. Next, cloud bases and ceilings. The cloud base is the lowest visible part of a cloud. The ceiling is the lowest broken or overcast layer that covers more than half the sky. This matters during instrument flight. If cloud base is at 800 feet AGL and your minimums are 1,000 feet, you'll need an alternate or a different approach. Cloud opacity also matters. Few equals few clouds, 1 to 2 octas. SCT equals scattered, 3 to 4 octas. BKN equals broken, 5 to 7 octas. OVC equals overcast, 8 octas. These categories help determine VFR, MVFR, or IFR conditions. Let's talk about cloud layers. Multiple layers may exist, each with different temperatures, icing risks, and turbulence. A stratified layer may be smooth, but the transition to cumulus above could bring bumps or convection. Layer depth is key for icing. Flying through a thin layer may mean light icing for a short period. A thick, saturated layer near freezing can cause moderate or severe icing, especially in stratiform clouds. Let's apply this. You're flying at 7,000 feet, outside air temp is -3 degrees Celsius, and you're in a layer of altostratus. Moisture plus temp plus time equals ice accumulation risk. Time to climb or descend. Another scenario, you see a solid layer of cumulus with towering tops. Even if the weather looks fine ahead, those clouds could hold embedded CBS. Avoid flying into buildups unless you're certain they're benign. High clouds like cirrus usually indicate approaching fronts. If you see increasing cirrus followed by altostratus and then nimbostratus, a warm front is coming with worsening visibility and steady precipitation. On the other hand, clear air between cumulus clouds usually means isolated convection, not necessarily a front. These patterns help you forecast weather visually from the cockpit. Now let's touch on fog, a cloud on the ground. It forms when the air cools to its dew point at the surface. Fog types include radiation fog, clear, calm nights. Advection fog, moist air over a cold surface. Upslope fog, moist air lifted over terrain. Steam fog, cold air over warm water. Fog reduces visibility to less than 1,000 meters, often grounding VFR traffic and requiring IFR ops. Always check METARs and TAFs for fog risks in the early morning or near coastlines. Let's look at an example META. This means scattered clouds at 2,000 feet, broken at 4,000 feet, good visibility, and a temperature dew point spread of 3 degrees Celsius. Fog is unlikely, but low clouds may limit VFR descent. Another tip, if temp and dew point converge, watch for rapid cloud formation. A 1 to 2 degrees Celsius spread often precedes fog or low stratus, especially at night or early morning. Let's summarize what cloud types mean for pilots. Stratus, low ceilings, poor vis. Cumulus, bumps and thermals. Altostratus, instrument flight likely. Cirrus, change is coming. Cumulonimbus, steer clear always. To wrap up part 1, clouds aren't just scenery, they're flight critical indicators. By learning to read the sky, you can predict turbulence, icing, visibility, and weather trends before your instruments confirm it. In the next episode, we'll go further into precipitation types, how clouds generate them, and what risks each kind poses, from drizzle to hail to freezing rain. See you in Meteorology number 28, Clouds and Precipitation, Part 2.